In this learning objective, we're going to extend our net present value analysis to compare two investments projects using the net present value method. To compare competing investment projects using the net present value method, we can use two different approaches, a total cost approach or an incremental cost approach. Let's take a look at an example. We'll begin with the total cost approach. The white company has two alternatives. It can, one, remodel an old or existing car wash, or it can tear down the existing car wash and install a new one. The company has a discount rate or required rate of return of 10%. And we're given information regarding the annual revenues and annual cash operating costs of both the new and the old car wash. If we install the new car wash, we're told it will cost $300,000, have a productive life of 10 years, have a salvage value at the end of 10 years of $7,000. We'll also have to perform some maintenance on the new car wash. We'll need to spend $50,000 on new brushes at the end of 6 years. And the salvage value of the old car wash that we're going to tear down today, that is $40,000. So let's go ahead and look at the net present value of installing a new car wash. If we install the new car wash, we have two cash flows at time zero. We have the initial cost of the new car wash, which was $300,000. That was a cash outflow. And we had a $40,000 cash inflow from salvaging or selling the old car wash equipment. The annual cash inflows for the new car wash were $60,000 a year. So we multiply those by the present value an interest annuity factor for 10 years and 10% interest, which was 6.145, and get a present value of $368,700. Next, we were told that we were going to need to replace the brushes in year 6 on the new car wash at a cost of $50,000, which has a present value of $28,200. And again, we multiply the $50,000 by a present value interest factor for a lump sum, 6 years and 10%. Finally, at the end of the 10-year period, we'll be able to salvage or sell this new car wash equipment for $7,000, and that has a present value today of $2,702. As a last step, recall, we add together all of the positive and negative cash flows, the present value, and we find the project has a positive net present value of $83,202. So buying the new car wash makes sense, but we still need to calculate the net present value of keeping the old car wash and then compare the two. If we keep the old car wash and remodel it, we're going to need to spend $175,000 today remodeling the car wash, and we'll need to replace brushes at the end of 6 years at a cost of $80,000. Let's look at the present value of this second alternative. Again, at time zero today, we'll spend $175,000 remodeling the old car wash. We had annual net cash inflows right now with our old car wash of $45,000 a year. And again, that's a 10-year annuity at a 10% interest rate. So we multiply the $45,000 by the 6.145, which is our present value interest factor for annuity, 10 years and 10%. And we get a present value of $276,525. Finally, we needed to consider the cost of replacing the brushes in 6 years on the old car wash at a cost of $80,000, which has a present value today of $45,120. So the net present value of retaining or keeping the old car wash, the existing one, is $56,405. When we compare this with the $83,202 net present value of investing in a new car wash, we can see that we should invest in the new car wash. It will provide us with a higher net present value. In fact, we will increase our net present value by $26,797 by making the new investment. Now, rather than use a total cost approach, we could have also considered an incremental cost approach. Under the incremental cost approach, only the cash flows that differ between the two alternatives are considered. let's look at analysis of White Company's decision using the incremental cost approach. First, the incremental cost, or the difference in cost at time zero, were the old car wash versus buying the new car wash. The new one was going to cost $300,000. Upgrading the old one was going to cost $175,000. So we would have a savings of, or an additional cost rather, of installing the new car wash of $125,000. This was going to be reduced by the salvage value of the old equipment. We could sell the old equipment for $40,000. And again, since both of those cash flows are occurring at time zero, we don't need to discount them back. Their present value equals the nominal cash flow. Let's go ahead and look at the additional incremental cash flows. The cost of the brushes. We were going to need to spend $80,000 to replace the brushes on the old car wash versus only $50,000 for the brushes on the new car wash. So if we go with a new car wash, we'll save $30,000 in year 6. The present value of that cash flow today, discounted again at 10% for 6 years, is $16,920. The next incremental cash flow that we'll consider is the increased annual cash flows from operating the car wash. The annual cash flows for the old car wash were going to be $45,000 a year versus $60,000 for the new car wash. So we would have an incremental cash flow with a new car wash of $15,000 a year for 10 years. And the present value of that annuity is $92,175. Finally, if we go with a new car wash, we were going to be able to salvage it at the end of 10 years for $7,000. That has a present value of $2,702. When we sum together the present value of all of our cash inflows and outflows, we get the net present value of $26,797. This is the same answer we got by comparing the difference in our two total cost approaches, or by focusing simply on incremental cash flows. Let's look at another situation where we might be comparing investment projects. In this case, we're going to consider what we call least cost decisions. In decisions where revenues are not directly involved, managers want to choose the alternative that has the lowest total cost from a present value perspective. Let's look at a decision by the home furniture company. In order to operate its business, the home furniture company needs a delivery truck to deliver furniture. And right now, the home furniture company is trying to decide whether to spend money overhauling an old existing delivery truck, or should we purchase a new delivery truck. The company has a discount rate of 10%. And in this particular decision, we're assuming that we aren't going to impact our furniture sales by whether we deliver the furniture in an old truck or a new truck. So we're really looking at, when we focus on our incremental costs, only the difference in the cost of operating the two trucks and the cost of overhauling it versus the cost of buying a new delivery truck. Here's the information we need for our decisions. For the old truck, if we're going to overhaul it, we're going to spend $4,500 now. The old truck has an annual operating cost of $10,000 per year, and we think that there will be a salvage value in 5 years of $250. If we sold the old truck now, we could get $9,000 for it. Our other option is to purchase a new truck, and the new truck would cost $21,000. And notice it has lower annual operating costs, $6,000 a year compared to the $10,000. And we think the new truck would have a salvage value in 5 years of $3,000. Let's go ahead and look at the present value of the cash flows associated with keeping the old truck or purchasing the new truck. First, let's look at the cash flows associated with buying the new truck. We had a cash outflow now of $21,000 to purchase the new truck, but we could get a trade-in on our old truck of $9,000. That was going to be a cash inflow. The annual operating cost of a new truck would be $6,000 a year for 5 years, and that has a present value of $22,746. And again, notice that's a cash outflow, that's a cost. At the end of the 5 years, we think we could sell or salvage our new truck for $3,000, and that's a cash inflow that has a present value of $1,863. When we add up the present value of all these cash flows, we find a net present value of negative $32,883. Now, Obviously, if we had a choice, we wouldn't buy a new truck. But the truth of the matter is we need a delivery truck to deliver our furniture. So we're going to have to pick the alternative that has the lowest cost from a present value perspective. Let's go ahead and look at the present value of the cash flows associated with keeping the old truck. If we keep the old truck, we're going to spend $4,500 today overhauling the truck. And then the annual operating costs were going to be $10,000 a year for 5 years, which the present value of that is negative $37,910. And then we think we'll be able to salvage the old truck for a measly $250 in 5 years from now. Notice that only has a present value today of $155. When we sum together the present value of all these cash flows, we get negative $42,255. Again, given our choices, we don't want to do anything that has a negative net present value. But since we need a delivery truck, we're going to want to pick the one that has the lowest cost from a net present value perspective. And that appears to be buying the new truck. In purchasing the new truck, we will have a lower overall costs. This is again an example of a least cost decision. And the net present value in favor of purchasing the new truck is $9,372. Some other examples of least cost decisions might be needing to install safety equipment and needing to install pollution control equipment mandated by the EPA. Again, given a choice, we wouldn't do it since it involves a cash outlay or cost. But if we have to do it, we want to pick the alternative that has the lowest cost on a net present value basis.